Today we're going to be working on exercise 10D. This is going to be applications to probability, applications referring to the counting methods we've learnt. Our learning intentions are to apply counting methods to probability. Our success criteria is can calculate probability by applying counting methods to find the number of outcomes in the event and sample space. Here's a reminder of the probability formula. Okay, remember, if you want to find the probability of some event A happening, you've got to figure out the number of outcomes in that event A, and you divide it by the number of outcomes in the sample space. Counting methods is a way that's going to help us do that, especially for events that have very large numbers of outcomes. We're going to jump straight into an example. A committee of 3 is to be chosen from a group of 4 men and 5 women. Find the probability that the committee contains all men. Okay, let's think. We're choosing 3, and they can only come from the group of men. So we can use counting methods to figure out the number of outcomes in that event. Choosing from 4 men, 3 of them, which implies that from the 5 women, we don't choose anyone. Okay, I know that's equal to 1, but I placed them next to each other, so I've accounted for all the different possible combinations. So P are men, I should write this down. This is the number of outcomes in your event. You need to divide it by the number of outcomes in your sample space. The number of outcomes in your sample space is just the total number of outcomes that can possibly happen by choosing 3 people from the total people that you have. So choosing 3 from 9 people. I'll make it clear. The top comes from the number of elements in men, and the bottom comes from the number of elements in your sample space. This is exactly our probability formula. Okay, let's work this out. 4 choose 3 is 4 factorial over 3 factorial 1 factorial. And we multiply it by 5 choose 0. Choosing no one from 5 women, there's only one way to do it. So I'm not going to even write it down, but I know that at the bottom I've got to do 9 choose 3. So that's 3 factorial, 6 factorial. Okay. Now the number in the numerator turns out to be 4 times 3 times 2 times 1. That 3 times 2 times 1 up there cancels out with the 3 factorial at the bottom. So the answer is just 4. The numerator is 4. Because 4 is remaining and you're still dividing it by 1. 4 divided by 1 is 4. We divide this by 9 factorial, which is 9 times 8 times 7, divided by 3 times 2 times 1. I've neglected to write down the numbers that come after 7 because you've already cancelled them out at the bottom. This is 4 divided by, okay, do some cancelling. 3 cancels with 9 and 2 cancels with 8. So in the denominator, we've got 3 times 4 times 7. 3 4s are 12. 12 times 7 is 84. So the probability of selecting 3 people from a group of 4 men and 5 women, and they all turn out to be men, is 4 out of 64. I simplify this, it's 1 out of 21. The probability of selecting 3 from a group of 4 men and 5 women, and you're only interested in the case where you have at least 1 woman. So that would be like, if a group has 1 woman, that's good. If it has 2, that's good. And if it's all 3 that are women, that's also okay. If it's questioned like this, then it turns out that the only case that can't work is the case where you don't have any women. 1 woman is equal to the probability of, from the entire set of possible ways, you minus the fact that you can't have no women. And identifying this fact is going to help us simplify this question, because otherwise you'd have to find the combinations of 1 woman, then 2 women, and 3 women, and add them together. So, one takeaway, the probability of no women, that means from the 5 women, you choose no one. 5, choose nothing. And from the men, you're going to choose all 3, because you've got to have a committee of 3. And the total number is from the 9 people, we choose any 3. Now we've worked it out already from a previous question. So let's sub in the values we know. 9 choose 3, we did that before in this example, and the answer was 84. At the top, 5 choose 0 is 1, 4 choose 3 is 4. So it's 1 take away 4 out of 84, which equals to 80 out of 84. Now this answer simplifies to 20 out of 21, which means it's very likely that you're going to have at least 1 woman in your committee of 3. Here's the last problem. A committee of 3 is to be chosen from a group of 4 men and 5 women. Find the probability that the committee contains exactly 2 men, given at least 1 man is chosen. That's a conditional probability. Let's set that up properly. PR of 2 men, given at least 1 man. Okay. Now, I'm going to attempt to apply my my conditional probability formula, which turns out to be the probability where you choose 2 men in intersection with having at least 1 man, divided by the probability of choosing at least 1 man. Now the numerator, we've got a subset situation going on, so I'll draw that subset out. It's great that if you noticed it, because the probability of having 2 men, I'll call this man, woman, because we're choosing 3 people and we only have 2 men. That's a subset where the bigger set has the case where you have at least 1 man. So the other outcomes in the bigger set would be man, woman, or man. The inner set represents exactly 2 men. The outer set represents more than 1 man. So there's a subset going on, which means the intersection is just the case where you get 2 men. So let's rewrite it. Because it's a subset, this numerator becomes just the probability where you select 2 men. And the denominator doesn't change. Okay, let's figure this out. We're going to do this separately. The probability where we choose 2 men is from the group of 4 men, choose 2. 4 choose 2, which means from the 5 women, we choose 1. And then we divide it by the total number of possible ways that we can choose, which was 84. We figured that out earlier. In the second part, we need to figure out the probability of having at least 1 man, which is the same as the complement of not having any men at all. Kind of like question B, where we use this complementary probability trick. So that turns out to be 1 minus choosing no men from 4 people. No men from 4 people. 4 choose 0, which means choosing 3 women from 5 women. 5 trues, 3. And then we divided by the total number of ways that can be chosen, which was 84. Let's simplify this. The top part, I'm going to do this in my head. 4 trues, 2. I already know it's 6. 5 trues, 1. There's another one of our identities at work. 5 trues, 1 is 5. So the answer becomes 6 times 5 over 64, which is 30 out of 64. In the other part, we need to work this out. That turns out to be 1 take away 4 trues, 0 is 1, 5 trues, 3 is 5 times 4 divided by 2, that's 10. 10 out of 84. And the answer to this is going to be 74 over 84. Have I made a mistake earlier? Yeah, I have. So that's 84. Always keep checking your mistakes. So at the end, we're almost at our answer. We're going to take our fraction for the probability of 2 men and divide it by the fraction for the probability of getting at least 1 man. So 2 men is 30 out of 84, and divided by more than 1 man is 74 out of 84. Okay, we're going to switch it around to cancel down. Common factors go away. And then 30 and 74 cancels to become 15 and 37. And that's our answer. The answer to the question, what's the probability that a committee of 3 is to be chosen from a group of 4 men and 5 women, and it happens to contain exactly 2 men. Given you know for a fact, like you've taken a peek at the committee and you see that there's at least 1 man there. You've seen a man in the group of 3. We're at the end of this exercise now. So let's review our learning intentions and success criteria. Learning intentions: to apply counting methods to probability. Success criteria: can calculate probability by applying counting methods to find the number of outcomes in the event and sample space. That's the key. You need to be very fluent with counting methods because the probability part comes afterwards. That's just applying what you've learned from chapter 9. Before I forget, please attempt the style questions that are at the end to check your understanding.